An intense mid-latitude cyclone is currently making its way into the US, and it's going to bring some very worrying implications considering winter storm warnings are already in effect over much of the United States. You can see this big pink area as winter storm warnings. Also have ice storm warnings in effect already, and this event is going on Sunday, so we have a lot of preparedness going on for this cyclone. Also going to have implications for severe weather. Our day 2 outlook with already enhanced risk, mostly driven by wind, but tornadoes are also possible, and there's this chance of hail. So we're already seeing severe weather, and we're going to see an intense winter storm with this cyclone. Today I'm going to be breaking this down, looking at the meteorology, primarily at the model runs, and explaining on how they're going to be working. So looking at our initialization here, this is at 12Z this morning. That's 2 hours ago, but pretty pretty new. You have this low pressure trough building in over here over the Rockies. Move forward here, you'll see the wrap run. It'll move this forward and actually starts deepening this trough. You can see our jet streaks here as well. The jet stream starts to go a little bit more on the bottom of that trough, and then it takes on a pretty neutral tilt, maybe a little bit positively, pretty neutral tilt there. Look at 250 though, however, we are going to see a lot of that stronger flow is still rounding the base of that trough. And if we go forward to model that will take us further, you'll see that the stronger flow will actually begin to round the base tomorrow on Sunday. There's some stronger flow coming in at 250 later on. Looking at vorticity at 500 millibars, this will help to fuel any surface lows and surface low development. You can see here we have a lot of vorticity advancing its way into the region. On Sunday morning at 12Z here, you can see a very large streak of vorticity. This is showing on all the models here. GFS has this, the European model has this, and the RAP model also has this. A pretty intense streak of vorticity, which is going to really help to deepen a surface low. Let's look at our surface map now, and I'm also going to zoom in right here. You guys can really see the intense development of this thing. So we already have development going on at initialization. This is at 9Z initialization, but very similar. You can see here, you get this intense surface low development. Just watch these isobars and as they just drop dramatically. Within 2 hours here, you can see that drops all the way to 1004 millibars. And you'll see that bullseye continue to deepen there until you have a very intense surface low there at 12Z in the morning. By that time, you'll already have precipitation going on over Kansas, and actually, we already do have some precip. Let's close the tab. Let me look at surface observations real quick. You'll see over Kansas. Let's click that. Zoom in here. Again, a little hard to tell, but you can see there's a snow symbol here. There's lots of fog here. This is indicating some sense of a warm front and cyclogenesis. Especially these rain symbols here and there. The precip is indicating that low pressure is beginning to form. So let's go back to our synoptic scale overview and just look at what's really fueling the system here. 850 millibars, we have a lot of warm air advection at initialization. Much of this area is under warm air advection. That's going to really help to, again, fuel that surface cyclone we talked about. And when we talk about that surface cyclone, also what's relevant is going to be relative humidity. Let's look at all the levels of the atmosphere here. We're going to use critical thickness, but it also has 500 millibar to 850 millibar relative humidity. So how much moisture is there in the air? You'll see there's this big plume of moisture right here over much of the United States right now. But as this cyclone here begins to form, you'll see this really just infect everywhere. And at 12Z, we talked about we had that surface low sitting right about here. And on that northwest side, you're going to see a lot of relative humidities, 95, 96 bullseye right here. That's going to be very well associated with an intense area of snowfall. So here's snowfall accumulation. I'm going to again zoom into, we'll go right here just to see where that surface low is. Let's look at the surface map one more time. See, we have a lot of cold air up here, a little bit drier, but closest to that surface low, you actually have quite a lot of moisture. 30-degree dew points when you're in that close vicinity there. So relative humidities here are very high across this region. That means we're going to see a lot of strong snowfall, especially because we're underneath freezing. Really precipitation type, you can see that right there. Heavy snowfall, very much possible for areas in Kansas. Look at 6-hour snow accumulations here. When you see that purple, that's going to be more than an inch an hour. So that's blizzard conditions already being shown by the RAP. Not to mention right here, I mean, that's a foot in 6 hours. So very much blizzard conditions here in regions of Kansas, especially right there in the center of the state. This will continue on into Missouri as well. It's just looking at the RAP model here. Very intense snowfall, blizzard conditions all over here. Central Illinois, central Indiana, maybe even moving up into parts of Ohio as well. A very intense winter weather here. And not to mention, freezing rain is a very important thing as well. So you go back here to Kansas again. Just keep in mind where this surface low is going. It's forming down here and just moving on to the east, but relatively slowly actually, just because of the size of that trough aloft. You can see this surface low here is going to slowly move to the east, but it's gonna be more stagnant. It's not nearly as quick and it's not zipping up as quickly. So there's lots of time for a lot of precipitation to fall. And we talked about all the warm air advection we were seeing, especially over this region. You can see lots of warm air advection. What this means actually is we're going to be seeing basically a warm nose over much of this region. With like 850 millibar temperatures, a lot of this region is actually freezing at 850 millibars, but at the surface you're below freezing, and that's a very good indicator of freezing rain. I took some soundings before the video started. Here is one from Missouri, right in kind of that region we talked about, and you can see on our SKU-T we have this large area of a warm nose. So if you can see on the SKU-T, this little line here, I really drew that badly, but this line is the 0 degrees Celsius, aka 32 degrees Fahrenheit. That's your freezing line. Anything on this half of the line is going to be above freezing temperatures. So you can see regions here very warm, and then suddenly, only about a kilometer from the surface, you do get that below freezing temperatures right here. And that is indicated, and it's right in the spot where you're going to see some freezing rain. This is a map again. This is a 12Z sounding. Let's see how we're looking at 12Z here. And our weather is going to be freezing rain right there in central Missouri. You can see it's already falling on the RAP model here. Similarly, I took another sounding, just moved it by accident. You can see on this map, on that, sounding, but you can see on this map we're right in that freezing rain bullseye, and this is an 18Z. We're going to be seeing even heavier freezing rain in regions kind of near southern Illinois, Evansville regions all in here. Right 18Z again. I took it right in this vicinity. Let's just take one off the RAP model while this is falling. Let's mess up this last sounding. You'll see what I'm talking about, a warm nose again, but you're going to see a much shallower freezing rate layer. So you can see a bigger warm nose here, and your freezing layer only starts right there around 300 meters from the surface, maybe 500 meters. It's very close to the ground, less than 2,000 feet for sure. So this rain is going to be falling as rain, but then freezing immediately not immediately, but you're going to see it freezing once it hits the surface. So that's where we're getting all this freezing rain from. And if you pay attention down here, the PW stands for precipitable water. A lot of water in the atmosphere that could be falling down here, not to mention the very saturated profile through basically all the way up to 300 millibars, lots of saturation there. So lots of rain will be falling and lots of rain will also be freezing. And that's a really big threat for this area. Something to look out for. And we talked about the National Weather Service already has plenty of warnings out for that risk. That's the primary risk we're going to be seeing with this system. There may be further implications. This NAM model is too fresh. Let's go forward a little bit. We're going to be seeing this system basically taking a due easterly line of pretty heavy snowfall. This is the total snow accumulation, so just pretty heavy snowfall area. Regions in Kansas and Nebraska here are definitely going to take the brunt of this. But this region here in this corridor right here, you can't see that very well. This corridor right here, that is definitely a worry for freezing rain. Freezing rain is also possible over just a very broad area. Let's look at that accumulation just really everywhere, regions along this Ohio River here. Just lots of freezing rain possible. That is definitely something to be looking out for. Another implication we have from this system is actually going to be severe weather. So due to the surface low being so intense, not to mention there's going to be plenty of forcing from this 500 millibar trough, a very strong trough here. 850 millibars, very strong wind speeds in our region here. You can see our enhanced risk region right here, bullseye right there, where we actually saw it on last week on Saturday as well. So a very similar area as we just saw some severe weather in, right there in that enhanced bullseye. Let's zoom in down here to our region so you can really see what's going on here. And 500 millibars, there's definitely this divergence, right? You can see our wind vectors are definitely spreading apart over this region we're looking at. 250 might even show it even better. Just lots of strong flow aloft. Really over this area, almost all of the flow is maximized. Not to mention a lot of warm air advection here. The ripple effect usually happens when you have warm air advection. The models just don't like to show it very well. And then again, we talked about that surface low, very intense, but it's also bringing a lot of moisture off of Mexico here. Right there, initialization, or not initialization, 12Z, Sunday morning, 6 o'clock Central Time. You'll see we already have 62 points shown by the NAM model. Let's see what the RAP says. Yeah, we already have some 62 points much more intense moisture right there close to the surface low as well. But throughout the day there, again, you'll see right there 18Z, probably prime storm time there. Plenty of moisture in that region. You can really see just how warm this air mass is on theta E. Just pretty widespread instability already building in there. Looking at Cape, we can look at most unstable Cape here, and we have some regions here hitting 1,000. Not nearly as intense Cape as we saw in the last setup. Pretty widespread region of Cape nonetheless. 1,000 joules per yeah, 1,000 joules per kilogram again. You'll see that instability starts to break apart right there around 18Z. That's probably when you're going to see the strongest storms. Let's take a few soundings as we usually do. They're very useful. Also, not to mention 3 Cape. So 3 Cape is also going to be quite maximized here over Louisiana, Mississippi, parts there. If this is coupled with surface vorticity in the right way, you could have another QLCS type setup we saw, saw last week. You can see it right here, vorticity boundary, and we're on vorticity boundary here, followed by a pretty nice region of 3 Cape there, which could help spin any surface vorticities into the vertical. You can see here, and here's our sounding from southern Texas, not a little bit removed from the risk area actually, but is still part of that. And you can see we have a little bit of curvature, more unidirectional, albeit, but a little bit of curvature in that photograph, especially if you're looking at it storm relatively, and pretty large cape profile with no cap in place at all. Let's look again. Let's take one here at 21Z, kind of in that bullseye region we talked about. Again, if you want more information, definitely check out the SPC. They have very good information on systems like this. Let's check out this next sounding, and again, a lot better curvature in this photograph here. We are lacking some bulk shear, so 0 to 6 kilometer shear. You can see on here, it does say 50s, however, but if you're looking from, I guess, 1 kilometer, 3 kilometers, there's not much shear going on there. But the bulk shear from 0 to 6, or yeah, 0 to 6, excuse me, 0 to 6 shear is definitely there. 3 to 6 shear is a little bit lacking. So we do lack some of that stronger forcing aloft. You're going to end up with some more high precipitation style stuff. You can also see a very saturated profile here. The dew point line is basically right with the temperature the entire time there. That could help aid in making some very high precipitation supercells if they are able to form. High precipitation storms are very likely though, and D Cape is actually not very strong at all. But 3 Cape is certainly there, so I am definitely worried about stronger storms, and specifically, I would be a little more worried about tornadoes personally, but definitely right in that bullseye. Here's STP. You can see it's very maximized right there at around 20Z, 21Z, right in the little bullseye there. I don't like to look at this only, but I'll look at it sometimes. You can see convergence there along that boundary as well, very strong. Let's actually check out some of the other cams and how they're showing this going. Here is updraft helicity probability. I like to look at this a lot. This takes 5 different models and kind of combines them. This is the HREF high resolution ensemble forecast. It's very nice. You can see this is Sunday at 18Z. So you can see which models have updraft helicity going on. A lot of them actually don't have very much storm coverage at that time. They wait until about 21Z. So that's when they really start to show up there. And as of now, we don't have any further data, but there is definitely this 30% bullseye there at 0Z, and you can see all these models with updraft helicity going on. The models are definitely showing this is going on. Let's look at the reflect. Okay, it's not allowing me to. That's okay. We can look at the HRRR on this website here. Let's check out the simulated reflectivity, just see how that's looking. HRRR shows storms trying to fire there around 18Z, which makes sense. You get that destabilization going on there at 16Z, but full destabilization, certainly 18Z makes sense here. You get those storms starting to pop up, and as they start to cluster together, you get this MCS, ULCS style that we saw last week, but not nearly as intense. It's like the NAM Nest as well. Very similar story, just you get that sound of the storm starting to fire there around 18Z, then you have a pretty quick transition to a linear mode, albeit some aspects of more discrete supercells here are definitely possible. Then this will move on to the east over as well. So let's just look at a broad overview of this as well, because we did look at everything. Here's the WPC page as well. Very useful maps. You can see in color freezing rain possible in this little region here. Heavy snowfall up there, especially in Kansas, Nebraska, but heavy snowfall near to that freezing rain. So there's kind of this mixture of winter weather going on everywhere here that could lead to some very dangerous road conditions or just living conditions. And a very similar story on Sunday, more intense on Sunday as well. this more defined surface low, as well as just a lot of moisture is able to advect northward. And you're going to see that freezing rain and that warm nose we talked about over much of this region. Again, most intense freezing rain is going to be somewhere in this corridor, but certainly, definitely possibilities out here. Models haven't been showing it up until now, but we are seeing this freezing rain continuing to move on to the east. So, and very large area of freezing rain is honestly the main concern, but the intense region of winter snowfall here as well, upwards of a foot in some of these regions here, definitely possible and definitely. So that should be about it for this forecast. A little bit shorter, but we do have, again, it's just a very intense mid latitude cyclone. It's pretty standard, but also just very intense 500 millimeter flow. Um, pretty very cold. Oh, not very cold for winter, but pretty cold air aloft. Really, just a very intense surface low will be going on. So I'll be interested to see how this goes on. But that's the end of this forecast. Thank you for watching. Stay safe out there, and I'll see you all next time.